Hi everyone, welcome to lecture 12 of our Intro to Neurotech decal. This is our last lecture and it's going to be kind of just a short conclusion of the decal and just a brief summary of the current state of the field and also where you can go from here. So first of all, this is our feedback form. I know we've brought this up a couple times already, but we'd really appreciate it if you could take the time right now to fill this out. We've only had a few responses, so we'd really appreciate having more feedback from you guys, especially since this was our first semester. And with the whole coronavirus thing, we know we have a lot to improve on. And so getting feedback from you guys would really, really help future semesters. And we really want to make this a better decal for all of you. So just go ahead and do that right now. Okay, I'm going to assume that you guys have at least gotten the form pulled up or at least the QR code scanned. So I'm just going to go ahead and you can fill this out later or as I go throughout this presentation. Okay, first of all, we're going to be talking about some medical developments right now in the field. And then later we'll go into kind of more the industry. And then I'll touch on a little bit of how coronavirus is actually affecting the neurotech field and then kind of some opportunities where you can go from here. So one really important application of neurotech in the medical field is brain implants, and this can involve deep brain stimulation, which is something we've mentioned before. This is usually associated with Parkinson's disease as a treatment, which can suppress Parkinson's symptoms such as tremors. And it can also be used for other neurological diseases such as epilepsy, Tourette syndrome, and even treatment of certain psychiatric conditions such as depression. Cochlear implants are also another really interesting application in the medical field. Basically, these are electric implants that can help restore hearing in people who are suffering from any sort of hearing impairment. So currently there are about 320,000 patients worldwide that are using this implant. The way they work is basically they're electronic devices that provide a sense of sound to someone who is profoundly deaf or severely hard of hearing. And basically, the electrical implants directly stimulate the auditory nerve in the brain, bypassing the damaged portion of the ear. However, a cochlear implant isn't a hearing aid and it doesn't actually restore normal hearing. What it does is it helps someone understand speech. But users can have a hard time like comprehending speech in environments with a lot of like background noise. And so that's where optogenetics comes in. Cochlear optogenetics helps improve the selectivity of the sound encoding, and the light can be used to activate the auditory nerve within smaller, called tonotopic ranges. So, kind of this is a way to improve that restoring hearing capability, and is kind of a newer improvement over the current cochlear implant model. So basically, overall, the goal of current medical research is to optimize long-term stability and biocompatibility of brain implants to make them viable for, everyday use, even beyond clinical trials. And this way, more people can use them, and it's a safer procedure in general. Okay, now I'm going to talk about some industry applications. So mostly just going to go through some really interesting startups I found. We've previously talked about things like Neuralink and Halo and Dream, and I know a group did a presentation on Kernel. So I'm just going to touch on a few that we haven't covered before and I think are really interesting. So first of all, we have Think, which is a startup and a product for combating stress and improving sleep. The way this works is they use neurostimulation. And so the user wears kind of this white triangle module on their forehead, and the black strips are embedded with data and signatures, and they're connected to that white module. So an app also connects to this, providing a control system to from their website, control the vibe of the experience. So their main product uses low levels of electrical stimulation to activate nerve pathways in the head and the neck. And these pathways are supposed to communicate with areas of the brain to help control stress levels and sleep quality. And so it's supposed to help consumers who, suffer from stress or struggle to sleep. And so this is an interesting, like, kind of low wave neurostimulation, or low impact, like, neurostimulation in the consumer market that I thought was pretty interesting. Another one is Neurable, which aims to make an everyday BCI. Brain computer interfaces want basically allow people to control software and devices using their brain activity. And so Neurable's actually first technology was VR, controlling virtual reality with your mind, but they wanted to go past that and they wanted to create everyday BCIs. So their next product is kind of a pair of headphones that are supposed to measure your cognitive state and also provide hands-free control for mobile devices. And their goal is to kind of bring BCI to the people in a way that you could use regularly just as a pair of headphones. So, for example, users would be able to send a text by thinking instead of typing. And also, because this is like connected to your brain activity, the idea is that these texts could carry like an emotional value beyond just the words of the message. So that's really cool. Another startup is Cognition, and this one is more of a medical application, but they help develop products that facilitate communication for people with speech pathologies and other communication difficulties through AI and augmented reality. So they're also working on BCI things, but basically this is more of a like facilitating communication. This one is really interesting. This is Melton, and this is a Japanese tech company. And they, quote unquote, intend to blur the lines between human and machines. And they're using biosignals in order to develop biosignal processing technology and robot technology. So they are creating cyborgs through artificial body and brain machine interfaces. And they want to unleash humans' physical limitation and maximize creativity. And so, one example is that they have developed a cyborg hand called Meltant Alpha with cybernetic augmentation technologies. So this is operated by a handheld control module, and it can like go through a range of motions and adjust the strength of its grip and all these things. And it's just like a really interesting kind of sci-fi sort of application. And they're also working on, like I said before, biosignal processing through analyzing neurological signals transmitted by the human brain. So very cool to see where this company goes. Emotive, we might have mentioned, but I'm not too sure. Emotive is a startup that develops both hardware and software in the neurotech space. They are largely focused in medical R&D. So like the headset involves a lot of EEG technologies, and they're supposed to help physicians with tasks like building 3D visualizations of the brain for diagnostic purposes. But they're also kind of developing a consumer device that can monitor electrical activity in the brain with the many EEG channels that they have and kind of be a wellness tracker in daily life. Okay, NeuroPace is also a more medical oriented company, but they're working to reduce epileptic seizures, which is a really big medical issue in the US. And basically, their product is the RNS system, which is an electrostimulation device that is implanted into a patient's brain and kind of sounds a little bit like DBS, but it's supposed to actually have reduced the incidence of epileptic seizures by 90% in clinical trials. So hopefully they can, grow more and help more patients. And lastly is Neuroscape. This one isn't exactly a company, it's a translational neuroscience center at UCSF. And actually, so as part of Neurotech, we got to go tour their space, and they're a really, really cool group of people. They're using, their idea is to build a bridge between, neuroscience and also technology. And for example, they're using video games. Actually, they're developing video games to support treatment of brain disorders such as ADHD, autism, depression, Parkinson's, and Alzheimer's disease, um, while also like tracking brain activity and kind of like doing a um, what's the word, like a feedback loop in order to determine how best to treat individual patients. And so they're trying to study basically novel neurodiagnostic and therapeutic approaches. And yeah, it's really interesting. Okay, now we're going to touch on coronavirus and how it has impacted the field of neurotechnology. Obviously, not directly applicable, but definitely there are still some impacts. So, first of all, COVID-19 has actually created some new opportunities for neurotechnology firms. Um, there's a bioelectronic medicine company called electroCore Medical, and their surface VNS therapy, which is vagus nerve stimulation therapy, has actually been used to alleviate respiratory symptoms in 2 patients with some pretty positive results. So that's kind of interesting. There's actually also a group of investigators that are interested in pursuing neuromodulation as an anti inflammatory pathway to combat the cytokine storms, I think that's how you pronounce it, that actually appear to play a major role in the fatalities due to coronavirus. So that would be a really promising application if it is pursued. Also in the long term, so obviously right now with staying at home and social distancing and people trying to avoid going to hospitals as much as possible, there's a surge in telemedicine, and this can potentially result in an increase in remote monitoring of brain function. Um, and this is kind of like something I read by a Rune Labs founder named Brian Pepin. He said over the next few years, we will see the first companies using wearable neurotech to manage chronic neurodegenerative and psychiatric conditions get significant market penetration and scale. At-home brain signal monitoring will only grow in importance as we improve our understanding of the links between brain signals and psychiatric disorders. So this is something that I think is really interesting. Um, the idea that people will start relying on like home monitoring rather than going to like the doctors. And so this is kind of a chance for neurotech to become maybe more consumer focused or more regular in everyday homes as people kind of get used to um, other alternatives than going to hospitals and stuff. Okay, and lastly, just where are we going to go from here? So you took this Neurotech decal, whether that was because you are really, really interested in Neurotech or because you just needed 2 units, up to you. But in this case, your interest in neurotechnology does not necessarily have to stop here. There's a lot of opportunities. For example, research. There are labs at Berkeley, at UCSF, that do research in this field. For example, just at Berkeley, there's the Coffer Lab, which does work on brain plasticity, and also the Carmina Lab that works on a neural and engineering basis of brain-machine interfacing. Personally, I'm in Chunlei Liu's lab. We do more related to like neuromodulation, but yeah, I'm sure if you're interested, you can find something. And also internships, obviously. There's a lot of startups we mentioned, a lot of companies. Yeah, and then lastly is Neurotech at Berkeley. So this decal was put on by our club, Neurotech at Berkeley. If you're interested, and hopefully if the semester isn't online next year, definitely look to apply. We have a few divisions, software, hardware, publications, education, outreach and consulting. So definitely check out our website if you're interested, or reach out to any of the facilitators for more information if you want to get involved with that. We definitely love to have you, and yeah, don't be afraid to apply. Okay. And lastly, we're just going to end at our feedback form again, in case you didn't catch it the first time. Um, yeah, it's been really great having you guys as a class. Obviously, this decal didn't go exactly the way that we had planned, but thank you guys for sticking in there with us. And I apologize for like our late lectures and for the weird timeline and kind of lack of communication at times. But hopefully, that's something we can improve on in the future. Um, yeah, have a great summer and stay safe, everyone. Don't forget to social distance and yeah, fill out the feedback form. Okay, thank you.